In order to understand the algorithm, now we will see the basic operations, how the algorithms are written and how they are read. So for the biology students, it will be little difficult to understand this, but I will try to teach in a very simple and efficient manner. Here we can see a very simple and first algorithm operation. Here we can see A, that is a variable, and B is a value. So in between A and B there is an arrow, left arrow, and left arrow means that we can, in a very simple explanation, we can say the left arrow is equal to. It means that this arrow can be assumed as equal to in mathematics, but generally in computer languages we do not use this equal to, but we use the left arrow key. So it means A, left arrow key, B means that the variable A is set to the value of B. So we can take the example of this one. Here we can see that B variable and its value is set to 2, and in another set of instructions we set A variable and its value is set to B. To understand this, we in the class 3 or 4 we have solved a very simple equation. For example, we know that A, for example, equal to B, B is equal to C. Then obviously we all know that then A will be equal to C. So in this example we can see that if B is set to the value of 2 and A is set to the value of B, that it means that A has the value of 2, because B is equal to 2 and A is equal to B, then A has the value of 2. So this is the second example of this very simple algorithm operations. And here we can see that this algo key is written A plus B. We all know we can add A into B, A minus B. A dot B means that A multiplication with B, A divided by B, and again A multiplied by B. And there is another notation is called A raised to power 2 means exponential number, A exponential. And we all know that addition, subtraction, multiplication, division and exponential of the numbers. Now we will see the example of arithmetic algorithm operations. So if we want to calculate the distance between the 2 points, then for this we need 2 coordinates, and these coordinates are needed in the Euclidean distance. And for this purpose we have 4 values, x1, y1, x2, y2. Then we have to calculate dx, and we set the value of dx to x2 minus x1 whole square. And similarly for the other point dy, we set the value of dy to y2 minus y1 whole square, and then we return and we get the answer. So in this we can see that x1, y1, x2, y2 compute the Euclidean distance between points with coordinates x1, y1, x2, y2. And if we have a real problem and we have 4 integers 0, 0, 3 and 4, and if we use this algorithm, we will get the answer 5. So in this case we can see here this 0 is we consider is x1, this 0 is y1, this 3 is x2, and this 4 is y2. And if we calculate by using this distance algorithm, then we have to calculate the dx value. So dx in this case, x2 is 3 minus x1 is again 0, and 3 minus 0 is 3. And then we have to take the square root of this one. And if we take the square root, we will get the value of 9. Then we will calculate dy. And for dy, we need the value of y2, that is 4. And we have to minus the value of y1, that is 0. And we get 4. And the square root of 4 is 16. Then we will calculate p underscore dx plus dy. So dx in this case is 9 and dy is 16, and we get the under root. So the value turns out to be 25. Under root is equal to 5. So we get this value of 5. So we can solve any of the problems by using this algorithm to find the distance between two coordinates. So this is the third example of this simple algorithm operation, and we use conditional algorithm. So in this case, we can see here is if written. This is condition, and this condition says if A is true, then go to B, and if A is not true means else, then go to C. So we can see here, if the statement A is true, execute instructions of B. Otherwise, execute instructions of C. And sometimes else C is omitted. And in this case, it means that either execute B or not, depending on whether A is true. So this is a very simple conditional algorithm, and I think it's very easy to understand. If A is true means that if A value is according to our condition set for some integer and it is true, then it will execute another set of instructions, that is B. And if A is not true, then it will bypass B and will go to the C. So now we will consider the example of this conditional algorithm. Here we can see that we have to calculate the maximum value from variable A and B. Again, this is the conditional. If A is less than B, then return to the B. Else means otherwise, return to the A. It's very simple. So we can see here, maximum A, B computes the maximum of the number A and B. And the example is, if maximum we have to calculate from the numbers 1 and 99, and it's very obvious 99 is the maximum number and it will return. It means that our answer will be 99.